Good morning. This is Dr. Schulman. It is the 6th. I'm going to be going over box plots, another variation. I did a really long standard deviation video last night where I go through all the programs, how to do it by hand. I'm going to do the same thing with the box plot. I guess when things start to get a little too crazy, I'll change it up. But that's my plan. I'll go over the box plot, the textbook, and some questions. So I'll show you how the box plot works. This stuff, the box plot's really good at showing spread. When I look at people's grades on Canvas, it actually shows me the box plot of everybody's answers and like how they did compare everybody's scores and how they compared to everybody else. But what is a box plot? It's showing the spread in versions of quartiles. So I'm going to try to make this really clear for everybody. I've done this one a million times. Box plots are used a ton, so I thought I'd try to make it very easy to see how it works. So here we go. I'm going to go right to the notes page. I'm in Intro to Stats 3.3, Variations and Box Plots. Oops. And I'm going to start just showing you an example and or what a box plot really is, and then how you see it in the different ones before going into the textbook. As usual, email me for questions. I heard that 1.1 and 1.2 weren't showing up for some folks. So you know what I did? I double checked and changed the links. So feel free to reach out for anything. So what does a box plot looks like? Sometimes it's called a box of Wishar plot. Sometimes it's written horizontally. Sometimes it's written vertically. I'll just tell you all the parts first before we do one. Okay. So this is what a box plot looks like. Now, it always needs a scale on the bottom. Doesn't have a scale on the bottom, you can't really tell the spread. What are the little parts of it? Well, oops, sorry. The little parts of it are like this. This is your minimum. This is your max. This is your Q1 or your first quartile. This is your Q2 or second quartile or median. And this is your Q3 or third quartile. But what does that actually mean? Okay, this means I have 0 to 25% of my scores. This is to 50% of my scores. That's why this is also called the median. This is 75% of my scores. And this is the 100% of my scores. I said it breaks it into quarters. That's what it does. That's why they're called quartiles, okay? So this means most of the scores are bunched together here between this number and this number. This means most of the scores are jumbled together. Its whole idea is just to show how spread out the numbers are. The best way to do this is an example. So I don't know, all examples are kind of the same. Let's do basketball. We'll do points scored in basketball. So let's say we scored 0 points one game. We scored 3 points. We scored 12 points. We scored 18 points. We scored 22 points. We scored 5 points. We scored 10 points. We scored 16 points. And then one day we went off for 45 points. Now you can already see that this 45 is an outlier, so we don't have to include it if we don't want to. But the first thing you do is you write it in order. So let's write these numbers in order. The first one is a 0, 3. Okay, 10, 12, 16, 18, 22. And then I scored 45 points. Now we can leave out the 45 or drop it in, and I'll show you how to work with it. And an outlier, what does an outlier mean? It's when you are over 2 standard deviations away from the mean. Away from, from the scores. So if you ever have a value that's over 2 standard deviations away, the computers are already going to show it's an outlier. Isn't that cool? All right, so things you need to make it. We need our minimum. We need our Q1. We need our Q2. We need our Q3. We need our max. We get other stuff too, but this is the stuff that we pretty much need to make the box plot. Minimum, smallest number. There she is, 0. Our maximum, biggest number, 45. Now our Q2 is just the median. So we already know the formula for median, okay? It's n plus 1 divided by 2. I have 1, 2, 3, 4, 5, 6, 7, 8 scores. 8 plus 1 divided by 2. Well, 9 divided by 2 is 4.5. So it's between 4 and 5. So 1, 2, 3, 4, and 5. So it's halfway between 12 and 16. It's 14. So our median is 14. So boom, boom, there's the line in the middle. All right, now our Q1, so I have 4 scores here. There's 4 scores from the line. I draw another line. Okay, so this is halfway between these. There's a formula for it too. It's just this times 25%. So 0.25 times n plus 1 over 2. But since it's such a small number, what's between 3 and 10? Well, 10 plus 3 is 13. And 13 cut in half is going to be what? 6.5. So we know it's going to be 6.5 here. 6.5. And then our last one is Q3. It's like kind of like 0.75 times this. Or we could just do what's halfway between 18 and 20, because here we go, and this is the other part of the box. So it's 18 and 22, it's 20. So we could draw it like this, right? But notice it's equal. It doesn't have the scale, right? So that's the most important part of a box plot. If you're going to draw it by hand, you need a scale. We're going from 0 to 45. So I think the best way to draw the scale is 0, 10, 20, 30, 40. Oh God. Sorry about that. Sometimes my pen doesn't want to be my friend. All right, 40. And finally 50. Okay, so our first dot's at 0. Ta-da! Our next one's at 6.5, so it's right here. A little bit, ooh, sorry. It's a little bit, it's in between these two, but a little bit on the 10 side. Our next line is at 14, so it's right there. A little bit closer to the halfway part. The next part's at 20. And finally, the last part is all the way at 45. This is the box plot for the picture. This shows us, boom, 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 that most of the scores are jammed between the 14 and the 20 mark. And if we look at our data, it's kind of true. Most of the scores are right here. Most of the scores do bunch up right here. That's how it shows us the spread. It shows us the spread. That was the whole thing. I know it's not too exciting, but if this is too hard for you, Excel does it for you. So does StatCrunch, but let's do it on Excel first. And I'm going to use the web version. I'm always going to try to go back and forth between which version I use for these things, just to make sure. I know a lot of people have the online version, so let's go online version. The weird numbers I made up for basketball scores were here we go. We call the scores. And we have our numbers. 0, 3, 10, 12, 16, 18, 22, and 45. Now, right away, if it wasn't ordered, we can go over here and we could order them by sort and filter. Now, I'm just going to do the standard deviation just to see if 45 is indeed an outlier. So standard stdev dot s, because I'm sure I don't have every basketball score for the season. It's just for 9 games. 13.925. Is it over 2 away? 13 from the mean. It's got to be over 2 from the mean. So we also need the mean. So equal average. So what is the average of this? To get the mean. 15. 15 plus 13 plus 13 Is it 45? I don't know. Let's do it. So, well, we can just use this as a calculator. So this plus this plus this. It is. It is an outlier. It's an outlier by 2. So when we build it, when we build our box plot, it's going to show this as a dot. Excel's like, guess what? An outlier. We don't want it in it. So this graph will look a little different from mine, and it'll also be vertical. Okay, and just so you know, what did I just figure out? This is my mean, and it's the little X bar because it's not it's for sample. And this is the standard deviation. And this is, they just use a little S for this one. Okay. Now, these are the things we need. We need a minimum. We need a Q1. We need a Q2, which we know is the median. Well, I can put a little median next to it, which means 50% of the scores. I need a Q3. I need a max. Ta-da! Other things we can get. We can get the range. We can get the IQ range. Isn't that cool? There's an interquartile range. Wild. I'm trying to think of other things they might ask you for, but that's good for right now. Okay, so here we go. The minimum. Now, we barely have any numbers, so we know it's 0, but we can literally do equal minimum, and it does it for us. Isn't that nice? There's the minimum. Our Q1. This one's annoying to write. Nope, I don't need a max space. We can do equals. Sorry about that. Equals quartile. And we need the array, which we know it's from A1 to A9, but then you also need something else. You have to say which quartile it is. Notice that if I put 0, it would give me the minimum. 1 was the first, 2 is the second, 3 is the third, 4th is the max, but I'm just going to put a 1. Now for the median, you have 2 choices. You can write quartile or you can do equals median. Either way, and get the right answer. Notice that this one is different from mine because why? They took out the highest number. So the quartiles are going to be a little different. It knows that this is an outlier because it's a very smart program. You have the choice of adding outliers or taking them out. That is your choice. As long as you give me a reason, I'll be happy with it. So this means my Q3 is also going to be different. So here we go. Equals quartile. We know it's A1 to A9. Then we just need the third one for third quartile, 19. And our max equals max. It already knows what I want to do. A1 to A9. Boom. Our range is just the biggest minus the small. So if you can literally just do the max minus the min, there's our range. And our interquartile range is honestly just you subtract the quartiles. It's just the range of the box. So equals Q3 minus Q1. Now, these are a little off from mine, right? Why are they a little off? The computer threw that out. So that's why these numbers are a little bit different. So we get to see. Now, this took a little while, right? Guess what? We can cheat even further. We can just click insert. So I got to highlight the original data. I can just insert a plot, which is really nice. So you go insert to chart, go to the bottom. Oh, sorry. Where is it here? So go to statistical. On the downloaded version, it's at the bottom. There it is. Here we go. Now it has this. Now there's things we can do with this. One thing that I really like to do is I always want to make sure that I'm including the middle. Notice how it just changed. So as soon as I included the median, as soon as I included that middle number, what did it throw out? It threw this out as the outlier. Isn't that wild? I'm also going to turn on data labels. What does that do? It shows me what all my values are. And the general, that's okay. I'm just going to put a white fill around them so I can see all the values. Okay, awesome. And then I'd probably just change the title to be points per game. Or you can say your basketball scores or whatever makes sense to you. So let's look at this. Now it's a match. But when it threw it out, this became 8.25, which is what we had. This became 19. Now it all matched. Before, when I did not include the middle, right? When I excluded the middle, it's different, right? It's different. Let's see if these are exactly mine. 21, 4.75. There, it's 20 and 4.75 and not 4.75. So what did they do here? Neither one of them my original answers, because not only did I include the middle, but I also 0, 3, 10. Oh, I think I made a mistake. No, it's 8 numbers. No, this is right. So right here, they threw out the 14 when they cut the rest of them, which we hate doing, which is what I didn't do. That's what they did. They took out the middle. And you should never lose a data point. Losing a data point is tough. So let's actually leave that middle here. So let's include the middle. Boom. And we know, and they made this an outlier. That's why theirs are a little different from ours. Because once you throw this out, once we cover this up, that becomes the max. So it's going to change these middle values. I hope this was clear. Because it's if they had this 45 in, it'd be exactly like my numbers. So you can make the choice. I just hate throwing out data points. It's like, why are we going to throw out a data point to do our math, right? So every time I do a box plot here, I'm going to include the median. Let's see it on StatCrunch, right? Let's see how they do a box plot of these same numbers, and let's see what happens. Then we'll do the questions, but hopefully this is being clear. If it's not clear, guess what? We'll do the questions and hopefully make it really clear for everybody. So we go to MyMathLab and mastering. And we're gonna go to open MyMathLab. And I'm gonna go to StatCrunch. And I'm gonna go to visit the website, and I'm gonna just make a box plot. Open StatCrunch. Oh, okay. So let's go back here. Leave, I copied that. Go here. Well, barely any numbers. I can just write them in. I'll try to copy it one more time. Control C. Nice. Okay. So let's go to box plot. Here it is. So here's our first variable. We probably should have changed the points per game. Where do we want it? That's just if you want on a different page. Group by, I believe it's just the variable one. Okay. That's if we have more. Use fences to identify outliers. Nice. If you want it horizontally, I like it horizontally. That's just me. Dividers, basic colors. Okay, let's see what it looks like. Oh, that does not look right. Let's try it again. So we're gonna go to box plot. There we go. I'm gonna just leave it how it normally is. I'm just gonna click compute. Ta-da. Cool. As soon as I just left it and hit compute, we got everything. I want the values. If I hover, will they show me them? Number of values 8, number of outliers, perfect. We got the interquartile range, the upper limit's 22, the Q3 is 20, the median's 14, 6.5, and the lower limit is 0. Ta-da. So how do we take out the outliers ourselves? I try to show you over here. Basically, as long as you find your mean and you see if any number is over 2 standard deviations away, you'll see if it's an outlier and you can throw it out. I like having every data piece in there, but computer programs will automatically knock them out as outliers. So I hope that was fast. I always don't want these to be like forever long. I know the last one took a little too long, but this is how you do it by hand. Sorry, lots of emails. Feel free to bother me whenever you want. Um, okay, so we're gonna do these problems in 3.3, and I'll go over whatever I think you need, but if you want to just do the numbers in general by hand, that's cool. But notice that my numbers were off because I did not throw this outlier out. If you draw the graph and you're like, wow, that's way off, do it again. Just reorder the numbers with it, cut it into 4 places. You're going to get everything correct. If you want to go the long way, you want to know exactly an outlier. Is it 2 standard deviations away from the mean? So guess what? We're getting into it. Uh-huh. So we're going to go to MyMathLab and Mastery. I'm going to open the book. We're going to go to chapter 3.3. Whatever they have in there, I'm assuming it's mostly box plots, but we'll find out together. So here's my e-text contents. I'm going to go to Pearson. I'm going to open a whole book. Sorry about the 8 zillion tabs. All right, so we're going to go to 3.3. These are all the standard deviations I did last night. And here we go. 3.3. Measures of relative standing and box plots. A lot longer, but title in line. All right, let me close this. Ooh, the first thing they show you is z-scores. That's nice. Okay, so z-scores are a little different, but I'll go through them. I'll go through whatever we need. So this selection introduces us to measures of relative standing and numbers showing the locations of data values to other values within the data set. The most important concept is the z-score, which will be used often in following. So yeah, I didn't know z-score was going to be in here, so I'll show you z-score too. As well as quartiles, percentages, and box plots. All right, so what is the z-score? The z-score is found by converting a value into a standardized scale as given in the Philo definition. The definition shows that a z-score is the number of standard deviations that a data value is away from the mean. So remember, when we're more than 2 z-scores away, guess what it is? It's an outlier. So here's our z-score. A z-score, or the standard value, is the number of standard deviations that a given value x is above or below the mean. So here we go. Now, this shows us how far we are away from the mean, and they have it 2 different, one for sample and one for population. So remember, the z-score. Just think about how far my data point is from the mean. Cool? All right, so if it's a sample, notice it's the same letter. So if we've got a sample, your z-score is going to be the difference from the mean, so x minus x bar over your standard deviation. That's what this means. So your data point minus the mean over your SD. Whoa, fancy. Sorry, I don't know how that circle got there. And if you got the population, it's the same thing. They just use different notation, but it's still a z. So it's the x minus mu over standard deviation. Same thing. And we go 2 decimals. The round off motivated by the format is in a z-score table. Okay. Example A illustrates how z-scores can be used to compare values, even if they come from different populations. That's interesting. So let's go back into it. A z-score is a number of standard deviations above or below the mean, expressed with numbers with no units of measurement. Using the range rule of thumb, introduce the data value is significantly low if the z-score is -2 or plus 2. That's what might be an outlier. If an individual data is less than the mean, its z-score is negative, which makes sense. Okay, we can do this one. So If we have 99 degrees Fahrenheit of an adult with a sample of 98.20 and a standard deviation of 0.6, then we've got the weight. So which of the following is more extreme? So it's just we're able to look at data from two different places at once and compare them. That's what the z-score does. It's like the critical value that we did before. We're just trying to compare two different things. So here, I'll do this too, and then we'll keep going. So the z-score, and we're talking just a regular person. We probably don't have everybody. You see, that's a sample mean, so that's how we know we're using this notation. So basically, we just take the data point, we subtract this, we just divide it by the standard deviation, which is 0.62. That's all this means. So what is 99 minus 98.20? Well, that's just 0.8 over 0.62. And remember, we got to round this to two decimal places. If you think I lied about the first one, we're dividing it by 0.62. It is 1.29. So two decimal places, boom. And we're going to use the z-scores a lot later. It's weird that it's in this part, but hey, not going to get complaints from me. 5.7790 minus 5.63930, and the standard deviation is 0.06194. So let's see what this one is. 5.7790 minus 5.63930 divided by 0.06194. And this z-score is 2.26. You have to round because this one's bigger than 5. So 2.26. The second one is more extreme. All right, I hope that was clear. Let's see if this is what they got. Yay, we got it. Cool. Significantly low and significantly high. That makes sense. What else we got? Okay, a percentile. Percentiles are the measure of location, which divide a set of data into 100 groups with about 1% of value in each group. Percentile scores, people confuse these a lot. Like I score above or below this percentile. So it's basically just breaking the data into 100 pieces. So remember, cent is 100 per, we divide by 100 and we're tiling it. So that's what it means. So divide by 100, and then we're tiling it. So then we're separating it into every piece. That's how I think about it. Okay, cool. So the 50 percentile has about 50% of the data below it, which is fine. When we get a little formula. Okay. Positive find the percentile that corresponds to a particular data is given by the following. So we've got percentile value. So we're just going to put a PV for percentile value. The value is less than X. Value is less. Divided by the total values. And then we times it by 100. These are really easy. They shouldn't be too crazy. So which one do we have? So we have this value. So just do it with you as if you're seeing it for the first time. These wait times are arranged in increasing order in table 3-6. Find the percentile of 45 minutes, right? So to get this, we have to find all the values less than 45, divide by the total number of this. So this is for 45. So it's a percentile of 45 is what we're looking for. I usually use a subscript, so I'm not crazy. So how many values are less than 45? Well, if we go here, well, first I want to know the total. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm 10 by 1, 2, 3, 4, 5. What's 10 times 5? 50. That's how I didn't have to count them all. And we want all the ones that are less than 45. But that's a lot to count, so I'm going to go the other way. So you ready? I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So if I have 13 that are bigger, 50 minus 13 is going to give me the smaller ones. So it's 37. So this means there's 37 that are smaller. So basically to do the formula, all we have to do is 37 divided by 50 times 100. And that'll give us our percentile. And then we'll see if we're right. Guess what? We all make mistakes, but this is how it makes sense to me. 37 divided by 50 is 0.74. We times it by 100. This should be the 74th percentile. Let's find out together. Ooh. Trying to write too far near the bottom. What? 72? I missed it? Number of values less than X. Oh, because I have to include this one. Ha 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 ha. So yeah, I counted it wrong when I subtracted because I had to include the 45 because it's all these less. So it's not 13, it's 14. Sorry. 14 would make this what? 50 minus 14 is how much? If we get confused, we use this. Guess what? We all make mistakes. That means we're learning. So it's 36. So we need 36 divided by 50 times 100. 72, so it's 72%. But we all make mistakes. That was pretty close. Who would want to count all these though, right? Crazy. So 10, 20, 30, 31, 32, 33, 34, 35, 36. Ta-da, I guess it wasn't that bad because there's 10 in a row. Okay, here we go. Some more notations. Okay. Oh, see, look, P of K. I had the same thing. I guess great minds, right? N is the total values, but that's for the sample. If it was the big N, it'd be the whole thing. K is the percentile being used. L is your position. Okay, haven't seen that one before. And then we have P of K, which gives us the percentile. I use the subscript. A lot of times we use subscripts just because they make stuff easier. Like I didn't even know that it was going to be 45 because I want to see this just like you're seeing it in this book. I haven't used this book before. So P of K, it's just how usual in math works. Okay, that's fun. Flow charts. Here's another one. This is using different notation. So let's look at the formula with the notation. L of K over 100. What? This must be a different problem. From figure, we see that sample data is already sorted, so we proceed to find the locator L. We use K as 25 to find the 20. Nice. This is if you want to go backwards. Oh, because they want to find the 25th percentile. Okay, so let's do this. So we want to get the 25th percentile. We're just going to use the same formula but they want us to go backwards. So they want to get this value, which is a little weird, but that's okay. So if you were looking for a percentile, we're looking for the 25th percentile, and we don't know it, right? But we already have the 25. We want to use the original formula. I'll first show it backwards. So if we want to do the 25th percentile, right? The value we need is what we want. So in our case, that's the position that we're looking for. Oh, they want to call it L. We had the X before, that's fine. The total values, our N is 50, because we have 50 values, and we times it by 100. They did it this way. So let's see if we get the same answer. The value locator L, this computation we use K is 25 because we were trying to find the value of the 25th percentile. All right, so I did it this way. I used the formula above. Let's see what happens if we don't do that. So they got 12.5. Let's see if using the top formula is going to give us the same thing. So 25 equals, well, this is just 100L over 50. And then we have to multiply this because basically I'm going to cross multiply. Doesn't work, we'll just use the other formula. So I have 100L equals 25 times 50. You don't know what 25 times 50 is. You can do 25 times 5 and add the 0. We can just do it this way. 1250. And we divide by 100. Oh, God. And we divide by 100. We divide by 100. So to divide this by 100, we're just going to text the 0, make a decimal here, and we got L is 12.5. What did they get? Using their weird mixed up way of doing the formula. The same thing. So that's the beauty of math. It doesn't matter which way you want to do the formula. You can use the formula exactly how they gave it to you above. The PV values less than X over the total values times 100, right? We could totally do it this way. Get the right answer, or we can come, or they moved the formula around, which is fine, and you get the same thing. So L equals K over 100 times N. I don't like it, but guess what? You still get the same answer. L is what we're looking for. The K is the value, so that's the 25. And the N is how many terms we have, and we had 50 terms. Either way, you end up with the 12.5. I just always like to use the same formula over and over again. Like if they give us this formula, here, I'll write it again. This was their formula. So their PV, right? Oh, God. Their PV, and I'll use the letters they want. Instead of X, they wanted L for location, right? They wanted L for location over the total values times 100. Their total values is N times 100. Perfect. K is also what they're giving for PV. So K is the computation that they want, which is totally fine. So K and PV are pretty much the same thing. This is why I think it's weird when they use different values. This is the percentile value, which they just gave us to before. They're also telling us that is K. I hate when they use two letters for the same thing. It kind of annoys me, but you can use this formula or use the one above it, which is the L equals K over 100 times N. Why give you two formulas mixed up for the same reason? I have no idea, but that's okay. Try not to get too confused. I'd use the top one. That's how I would do it every time. Because why remember two separate formulas when the top one just makes sense to you? Or instead of all that, instead of using the different letters, I would just do this because it says what it means. Percentile value equals the values less than X over the total values times 100. That's what I would do every time. But here are some short ways to think about it. All right, quartiles, 25%, your median, 30, we did that. See, quartiles, 25%, 50% of the median, and third one, we've got okay, so they give us different quartile ranges. This is not fun. I only gave you the first one, so let's see what other things they want. The IQ range, the only one I've ever really used, just Q3 minus Q1, because it's the box. The semi one, so this is cutting it in half. So the semi IQ range is this value chopped in half. The mid quartile is the average of the quartiles, which I don't know what you'd ever use this for. But guess what? I'm not complaining. And then the 10th to 90th percentile, I get why this is used. This is used for scores. So this is just your 90th percentile minus your 10th percentile. None of that is too crazy. What's the one that's most used? The top one. what's the 5 number summary? That's with the minimum. Yeah, that's what I started with because this is the mostly used stuff for this idea. And I'm assuming we're at the end. Here's the box plot. This one looks like it's a what? An outlier that we'd probably throw away. Or maybe not. No, because there's other numbers here. It isn't thrown away. It's just all the numbers are bunched here. Cool. We got some box plots. Okay. Outliers. Beautiful. This is important. Okay, we noted that the description of outliers is somewhat vague, but for the purposes of this constructing a modified box plot, we consider outliers to meet specific values based on quartiles or interquartile range. Okay, so I always thought an outlier, every time I've ever done an outlier, it was over 2 standard deviations away from the mean. But we're going to find theirs, and maybe it'll be the same. Interquartile range is notated by Q3 minus Q1. Find the quartiles 1, 2, and 3. Find the range and evaluate 1.5 times IQ range. All right, so here we go. It's much shorter. I kind of like that it's shorter for this outlier for the box plot. So this is the way that I've always seen it, over 2SD away from mean, which is fine. They're saying it's 1.5 times IQR. So either above or below this. So let's actually use our example. Choose our example. So we found that this was going to be an outlier because it was more than 2 standard deviations away from the mean. So let's get our IQ range. We have it. It's 10.75. So if I take 10.75 and I'll just put outlier because I'm going to use their definition. So I'm going to do equals 1.5 times, and that's just shift 8, this value. I want to see if that is bigger than 45, less than 45. We got 16.125. Does that make 22 and 18 also an outlier? Let's look back at their definition. Above Q3, okay, or below Q1. Okay, so I see what they mean. So this number, we have to go to Q3. So our Q3 is 19. So we have to do, so for this is the outlier value. And to get the actual outliers, what do we have to do? We have to take it, so to test. So this is the low outlier, and this is to be a high outlier. So either below the graph or above the graph. So we have to take this value, and either for the low outlier, we have to take the smallest one and subtract it. So I have to take Q1 and subtract this value. Do we have anything less than -7 for points? Nope. Okay, now for the high outlier, we have to take, we have to add it to it. So we have to take this value, the Q3, which our Q3 was 19. We have to add what to it? The outlier range and 35.125. This 45 is higher than that. So guess what? This becomes an outlier. Cool. So what did I do? I took this value. How to get the outlier value? I did 1.5 times what? The range. Now, if it's more than 1.5 times greater than Q3, or 1.5 times less than Q1, so if it's anything lower than this or higher than this, it's going to become an outlier. And I like it. I think it's probably a better way than my 2 standard deviations away from the mean. And we're going to question learning some new stuff. Box plots are skeletal or regular box plots, but some systems provide modified box plots on special points. And if I as above, nice. Okay, cool. I like it. Nice. This is how to find your outliers. And you got 2 outliers. I knew it because I knew this box plot looked like it had an outlier in it. I knew it looked freaking weird. It looked too far away. And in actuality, in this one, there were two outliers here. Cool. Lowest data value, that is not an outlier. Highest data value, that's not an outlier. And then we've got our two outliers. Cool. Okay. I showed you this in the beginning. This is how to do it on like 8 different programs. Exciting. Let's do the problems. All right, 2, 5, 10, 12, 14, 17. All right, let's get after it. Oops, that is not what we want. So let's do 2, 5, 10, and 12. Numero dos. The box plots shown below represent customer waiting times for two different waiting lines. Which line would you prefer, or does it not make a difference? Ah, cool. So this box means 50% of my time of waiting, I'm between 25 and 29 minutes. This box means between 50% of my time I'd be waiting only 26 to 28 minutes. I'd actually like to be in this line. But you have to explain. I would rather know that it's going to be between these two times and have a less of a range, even though I have a chance on line 1 to wait 21 minutes. I also have this one for 33 minutes. So if you're a gambling person, you'd be like, line 1 is better because I have a shot at only waiting 21 minutes. But I would rather be in this line. So I guess if I'm a gambler, line 1 has a shot at 21 minutes, right? If I don't want to gamble, right? I would pick line 2. It's more consistent. It's more reliable. Between 28 50% of the time, I will wait between 26 and 28 minutes. That's what I think. Your choice. Just give me a good reason. All right, let's look at 5. This one's a really hard concept, so really take your time doing 2 and thinking about it, okay? Let's look at 5. 5. Express all z-scores. Oh, we can do z-scores. Body data in appendix B, the highest measurement is 98. Okay. The 147 dystolic of females have a mean of this, and a standard deviation of this. What is the difference between the highest systolic blood pressure and the mean of systolic blood pressure for females? So they want the difference between the highest. That's the first question. So the highest is 147. Difference just means to subtract. And what is the mean? The mean here is 70.2. So that is our first answer, 70.2. We just subtract 147. And we are left with 76.8. That is the difference. Cool. Well, let's do B. How many standard deviations is that? So how many standard deviations is that difference found in point A? So how far away is this? So the standard deviation is 11.2, right? So that's part A, right? Now for part B, if I have a mean of 70.2, right? I always visualize the picture. And each standard deviation is 11 away. So if I go 11 one way, 11, this is 1 SD, minus 1 SD. So to be one standard deviation away, and remember, this is 68% of all the scores, okay? So 70.2 minus 11.2 is 59. Okay, so that's one standard deviation away. That's 59. And one standard deviation positive will be 70.2 plus 11.2 is 81.4. We're here. We're right here. 76.8. So we are one standard deviation away from the mean. Cool. Okay. Want to use X bar? They use X bar over here. Convert the highest one into a z-score. Okay, so you forgot the z-score. That's okay. Feel free to look up your formula so you don't get confused. But the z-score formula, in case you get confused, is x minus x bar over s. That's all it is. So what does that mean? Sorry. All right, so the z-scar for this case, so have a sample x minus x bar over s. What does this mean? Well, the first one is our what? It's our value, our 147. It is whatever number we want to work with. We want to find the z-score for this number. That's what we start. Then we have to subtract the mean, which is 70.2. How do I know that? It's right there. Then we just divide this by the standard deviation, which is 11.2. This will give us our z-score. So 147 minus 70.2 is 76.8. We're dividing it by what? 11.2. We're getting what? 6.85. 6.886. Because they always say two decimal places. So it's the answer is 6.86. And what do you have to do? You have to use the criteria characterized in 3-6. The highest blood pressure is significantly low, significantly high, or neither. So let's go to 3-6 to just double check everything. I always like double checking this stuff just to make sure it's clear. So we got a 6.86. So let's see what that number actually means for us. All right. If it is bigger than 2, is 6 bigger than 2? Oh, yeah. It's way bigger than 2. If it's less than -2, but yeah, it's a significantly high value. It's the highest one that they've recorded, so you know it's going to be this, but I just wanted to show you on the chart. Ta-da! Okay. Let's get back into it. I think this was the one. Nope, that was not the one. All right, so we did the first one. Okay, now we got to do the second. Oh, we did the first 2 problems, so let's do the rest. So we knocked out 2 and 5. Let's look at 10. Here's 10. Use the range rule of thumb. Ugh, annoying. Wait, am I on the right thing? No, I am on the right thing. Okay, I thought we did this already with the range rule of thumb. Use the range rule of thumb, identify values that are significantly low, values that are significantly high, and the values that are neither significantly low or significantly high. All right, so 10. The Wechsler IQ test measures intelligence of adults range 16 through 80. The mean test score is 100 and the standard deviation is 15. Oh, okay. Well, I was pretty close when I made that IQ example. I said the standard deviation was 10. So here we go. So here we have 100 And we know the standard deviation is 15. So one standard deviation away is 115. Two standard deviation is 130. So anything bigger than 130, I believe, would be significantly high. Okay, and then we've got 100 minus 15 is 85. And 85 minus 15 is 70. So I believe these are going to be significantly low. Okay, so this is what I think it is. I think that values that are low are anything less, anything less than 70. That's going to be low. The high ones are going to be anything greater than 130. And the neither, the ones that are in the middle, are going to be between 70. We can go like this. Greater than or equal to 70, or less than or equal to 130 will be neither. That's what I think the answer is. But let's look at their range rule of thumb yet again. Why do they keep giving us this range rule of thumb? I have no idea, but let's check it out. Control F, look up range rule. Okay, it's the exact same thing. Oh, minus less than -2. All right, so oh, I got my equal signs wrong. So significantly low if it's less than or equal to -2. And assuming ha ha ha. So it's less than or equal to. So ready? The only difference is the low is going to be less than or equal to. The high is going to be greater than or equal to. And the neither will not have these here. That's the only difference. Well, that's why you look them up. Feel free to look stuff up, but this is the answer, 130. Ta-da! And I'll do one more. Hopefully this is clear. Hopefully this makes sense to y'all. Let's do 12. Let's see what 12's got in store for us. Maybe I'll do another one, or I'll make another video after this one. What does 12 have to say for us? Oh, it's the same thing. Okay. So here's 12. We know it's 36.6. And we know it's 2.5. Boom, 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 boom. 36.6 plus 2.5. 39.1 plus 2.5. 41.6. So the high, significantly high, is x has to be greater than or equal to 41.6. Okay, let's do the other way. 36.6 minus 2.5. 34.1. All right, minus 2.5. 31.6. So that's fun. It's 10 away. It makes sense because it's 2.5. So the low is got to be less than or equal to 31.6. And the neither, guess what? It's going to be 31.6 is less than. Sorry, x is greater than 31.6 and less than 41.6. That's neither low nor high. All right, since that was so easy, let's do one more. Oh yeah, because there's a ton in here. I'll do some more. So I'll do 17, 18 as well. Let's see what 17 and 18 have for us. Okay, 17. Find the percentile. Cool. Corresponding to the given radiation level. So let's do this one. Okay, cool. So the percentile. if you forgot the weird formula, and we want to know at 0.48 and 1.47. So let's figure these out. So we can go back to the top, right? The PV, right? Percentile value, the value is less than X over the total values times 100. What? Sorry. PV, we know it's the value is less than X. You want to use the letters that's cool over we're gonna be timesing this by 100. I'm pretty sure it's got to be the total values because it's a percentile, and that's what we're gonna do. Now you can make this K or L for location. And this is the, God, I forgot what the random letters were, but you can use whatever letters you want. This is what I'm going to do. Okay, so we got 0.48. We want to know what percentile that is. It's not going to be crazy, I promise. So first, figure out how many total values we have. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we got 50. We got 50 total values. How many values are less than X? So we got 0.48. How many values less than X? 1, 2, 3. And we're just going to multiply that by 100. Wasn't that simple? I hope so. And so we've got 3 divided by 50 times 100. Guess I'm at 6%. So this 0.48, you're in the 6th percentile. Ta-da! 6, what's not percent? It's 6th percentile. So I'm gonna actually write it. Oh, let's do the 1.47. So we know the PV, what we're looking for, is going to be the other values less than this over 50 times 100. So how many values are less than 1.47? Well, we're already here. So it's all this business. So you ready? 10, 20, 30, 40, 41, 42, 43, 44, 45, 46 or less. Boom, boom. 46 divided by 50. 0.92 times 100. We are in the 92nd percentile. That means we scored at or above 90% of everybody else who's in this. This is 92 or better, like better than 92% of all the other ones, or higher than 92% or others. So that's the 92nd percentile. That was the ugliest circle. Okay, anything else? And let's look at 21. Yeah, I wanted to do one that was the other way. This will be the last one I do, okay? And when you're making the box plot, guess what? Look at the examples I did above. Just let Excel do the work or let StatCrunch do the work. If you want to do it by hand too, that's fine. This will be the last one I do. So percentile of 30, right? Okay, so we're going to do this exactly this. We want to find the value, right? We want to find the value. I want it in the right spot so it's not all over the place. So here's 21. We want percentile of 30. Okay, so just remember, what do we have to do to get this? We need to figure out this. So we have percentile of 30. So we know this is 30%. The 30th percentile, right? That's what we have. Now, if I have 30 equals, we want X, or in our case, L. We can use at least the L for location that they're like, over 50 times 100. That's all we're going to do. This is all I'm going to do. All right. Okay. I don't need the dot here because I already have the times 100. So this is the way I'm going to do it. We'll see if we get the right answer. So over 1, so 30 equals L times 100 over 50. So I'm just making this into a fraction. Top times top, bottom times bottom. This is what we're looking for. It's L times 100 over 50. Now I have to do this. Go boom, boom. Okay. So here, let me make this real nice and neat for us. 30 equals L over 50 times 100. The first move that I make when I'm doing the math here is this a fraction, I make that a fraction. Top times top, bottom times bottom. So my line is really 30 equals 100L. I like putting the numbers in front. 50 times 1 is 50. Now again, every number is a fraction. If this is a fraction, make this a fraction. Think about this is like whenever there's an equal sign in a fraction, think about like thorax and antennae. Butterfly rhymes with what? Cross multiply. 100 times L is 100L. 30 times 50. You can't do 30 times 50 in your head. That's okay. I do 3 times 5 and then add the zeros, but that's fine. 1,500. Divide by 100. Divide by 100. Boom, boom. The answer is 15. And we can check. We can make sure that that's 15. We can look at the table and make sure this is exactly what we want. 30th percentile. Find the list of indicated percent or quartile. Use the same list of cell phone radiation given before. Find the indicated percentile or quartile. Pretty sure it's 15. But when I look here, I'm not sure if that's the right value. So I'm going to double check. I'm going to go back. You know, if I'm not sure about something, I'm always just going to check it. So let's just check it. Percentile value equals the number of values less than x times the number of values times 100. Okay, so there's 15 values less than x for that one. To be in the 30th percentile, we want 15 values less than x. So we don't have to use this weird little method. So let's see. How can I check? How can I make sure that this was right, that this 15 is right? So ready? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5. This is 15, right? This is 15 less than this. So this is 0.97. Let's check it out. 0.97, right? So we know 0.97 is right here, right? So if we have 0.97, we should be able to get what? We should be able to get a 30 at the end. So PV equals or less than X, right? Over the total times 100. So if we have 0.97, we've got 15 less. So ready? So PV equals 15 over, we've got 50 in total times 100. Let's see if we're going to get that 30. PV equals 15 divided by 50 times 100. And lo and behold, yes, it is 30. So it does work. We got the answer. Work backwards for what we wanted. The answer is 15. 15 is less. If they want the exact value in the chart, you can use the 15, go right to the chart and see that this is what? 0.97. They said find the indicated percentile, or we know the value is 0.97. We know it's 15 for this one. Cool. Okay, so I want you to do the box plot yourself. I'll do 23. I'll just let you do the box plot yourself. Try it yourself, see if you can get these values. Let's do 23. 23 says Q3. What's Q3? Well, quartile 3 stands for 75%. So we already know what we want. So we know this has got to be 75 equals X over the total, which is 50 times 100. That's it. Okay, so here's the extra piece I'm going to throw in over 1. 100x over 50 equals 75. I'm going to use some more colors. Here we go. There's my thorax. There's my antenna. Butterfly rhymes with cross multiply. 100x equals 50 times 75. If you can't do it, I do 5 times 75 and add the 0. But if you can't do that, 50 times 75, 3750. Divide by 100. And we know this value is going to be 37.5. Good luck with your box plot. Let me know if you need help. Sorry this one was so long. I said it was going to be long, and it still was long, but hopefully this was useful. Anything's too confusing, trying to do them all in a row. Sometimes I mess up. So just call me out, or if you have questions, just let me know, and enjoy your day.